share my screen. So yes, this is our 7th episode of Wastewater Talk, and today's we're gonna talk about the sulfide balance in the drainage systems. A short introduction to the Wastewater Talk. So this program aims to promote knowledge exchange and the networking in the wastewater field. And every month we bring a new topic for discussion. And from the last month, we start providing 2 alternative meeting times, one in the morning at 10 o'clock and one in the afternoon at 15 o'clock, so that our participants at different locations in different time zones can all participate in our wastewater talk. So our goal is to share our passion in the wastewater management, wastewater technologies with you, and also more importantly, to get to know you, the experts or operators in the wastewater sector. And here I also, here I also put the website of this wastewater talk here. So later we will make this presentation available online. So everyone, if you would like to know more about wastewater talk, about the episodes in the past or plan in the future, you can check it out. And this month we talk about the sulfide balance, and next month we have our special episode about the EFAT in Munich this year. If you're going to be there in EFAT, you're welcome to visit our booth. And if you are not able to be on site, you can also join our wastewater talk to have a look what's new at EFAT this year. Yeah, so before we go further, I would like to have an introduction round about us, about our guest speaker, Professor Jess Bulletin, and also our participants. So yeah, for this episode, we invite a special guest speaker, the Professor Jess Bulletin from the Aalborg University. So Professor, would you like to introduce a little about yourself?
Sure. Yeah, so my name you already got, and I am a professor of environmental engineering. I have been working with sewer processes and all the related things since the mid-90s. And I have been doing research within chemical and biological processes. And I'll also come back to that. Modeling is a hobby of mine, and computer coding is a hobby of mine. So all this work has also led to writing computer programs. Yeah, I also do consultancy work, by the way. Well, I'll come back to that. So that's a little bit about me.
Thank you very much. The later Professor Fullerton will also give a presentation about the modeling or simulation software for the sulfide in the sewer systems. Then I will give a short introduction about myself. My name is Siqi Tong. I come from China and studied in Germany, and now I work as a project engineer at Unitechnics. I'm also the co-host of this wastewater talk, this program. I'm interested to learn about the wastewater management or different wastewater treatment technologies in other countries. So yeah, and I'm happy to know you. So now should be Klaus introduce himself, but unfortunately he's on a call now. So I will maybe ask my colleague Raghav to introduce a little about himself.
Hi, my name is Raghav and I'm from India. I'm currently working as an engineer, a project engineer like Siqi in the company Unitechnics. And I'm into this wastewater field for like 6 years, and I did my master's in specialization with water and wastewater technologies. And now I'm very much interested in the technology and like to exchange my knowledge and get new input from everyone all around the world, and trying to seek new technologies and new methods, and want to develop more in this field. So I'm happy to meet you all here and then exchange some useful info and have a nice talk. That's all from me. Thank you, Siqi.
Thank you, Raghav. Maybe someone would also like to introduce a little about yourself, and if you have problem with your microphone or you're not convenient to talk, you can also write something about yourself in the chat. So Katahina, would you like to introduce a little about yourself?
Yes, I hope you can hear me. I'm sitting across from Siqi, so I can also see her when I just look like this. And I'm also a project engineer at Unitechnics. I started last year, and I come from process engineering, biological process engineering. So wastewater treatment plants is more my thing, but I'm also learning a lot here. So I try to join every week. Thank you.
Thank you. So we still have looking at what's the name going? So we have a Galaxy M31. Can you hear us?
Yes, of course. Good morning, everybody.
Hello.
Hello. I am Hani from Egypt. I'm working as a water and wastewater plant designer, and I'm interested to hear about your techniques. And maybe I can consider in my design, and we can have some of cooperation maybe later on.
Yeah, that's great. Thank you very much. So we have Bibek Mishra. Can you hear us? Okay, so maybe not. Then we will go further. Hoodie from Nepal.
He sent something.
Oh, okay. That's great. So Hoodie sent something in the chat about himself. He's from Nepal and from the Nepal Engineering College. Okay, we also get the introduction from Kevil in the chat. So Srikant Alec, would you like to introduce a little?
Yeah.
Hi.
Hi. Nice to meet you again. My name is Srikant Alec. I'm from currently I'm living in Germany and working as a process engineer at municipal wastewater treatment plant Bad Krozingen. So my main aim is to know more about the sulfide balance and odor removal technologies. So that's it. Thank you. Yeah.
And you were also with us in the last episode, right?
Yeah, episode 6. Yeah, I was there.
Thank you.
Yeah.
So next we have Luis Mariska. Can you hear us?
Hi, morning.
Hello.
My name is Luis Mariscal. I'm Spanish, but since 2016 working in the United Kingdom in wastewater processes, and yeah, the same, trying to share knowledge and also interested about your technologies, about odor control and odor abatement. So thank you very much.
Thank you very much. So we still have Tagu Aditya Suyadi. Can you hear us?
Yes, hello.
Hello.
Hello, my name is Teguh Aditya Suyadi, and you can call me Teguh. I came from Indonesia. Currently, I am working as the effluent treatment plant supervisor in a pulp and paper industry.
Okay, thank you very much.
Thank you.
Welcome to join Wastewater Talk.
Thank you.
I think we have the last participant, El Hadi Said. Sorry for the pronunciation.
No, it's okay. It's okay. Hello.
Hello.
Nice to be with you. I'm Al-Haj and I'm operation coordinator in a wastewater plant. I'm from process engineering field and I'm working in UAE in the Middle East. And it's maybe some of you know that it's a big headache, like the H2S topic in the Middle East. And I'm here to learn as I want. Thank you.
Thank you and welcome. Okay, besides Klaus, we still have a participant, Asus. I think that's Okay, can you hear us?
Hello. Yes,
Hello.
yes, hello. I'm Zeynep Amin. I'm Iranian, but I'm connecting from Turkey. I have PhD degree in environmental engineering, especially I've worked about the wastewater sludge and drying it and composition by renewable energy by solar dryer. So that's my major. Thank you so much.
Thank you very much and welcome to Wastewater Talk. Now we have Klaus back.
I'm sorry, I had a private emergency, but I heard everything. So yeah, Klaus Jirk, my name. Siqi and me, we are providing a little bit organization for all of this, and I'm looking forward to all of your opinions and so on. And the current issue was a wish from some of our participants earlier. We had a similar issue like today already, like a little bit ago, like 6 months ago already, a little bit. And today we hope, yeah, it's already still interesting. Odors are still a problem, especially when it gets warmer. So I'm looking forward to everybody's opinion and yeah.
Good. Thank you. So I will go on with my presentation. Yeah. So as usual, a very quick introduction to the Unitechnics. We're an engineering company based in Germany. We deal with the odors, corrosions, extraneous water, any kind of problems that you could find in the sewer systems. So last year we just celebrated our 30th anniversary, and yeah, we offer the engineering consulting, investigate the indirect discharge for the municipalities. We also inspect the sewer systems with drones or with the camera boats. So, and then it's our topic today, the Sulfidus is a software we developed for simulate or modeling the hydrogen sulfide formation and emission in the sewer system. And then we have the products against the odor, corrosion, extraneous water, and rats. And for the special cases, we also designed the dosing and exhaust air treatment, which was the topic of the last episode. Yeah, so we will jump into today's topic. So to talk about the odor problems and to talk about the odor solutions, we first need to understand the odor problems in Germany. So you can see from this diagram here, from 1990 till now, the water consumption in Germany per capita has been decreasing rapidly, and with the less water consumption, there's also less wastewater generation, but we still have the same size of the sewer systems underground. Then that leads to a longer retention time of the wastewater in our sewer systems. So this will be a contributor to the formation of the malodors, such as the hydrogen sulfide and many other malodors. And another contributor in Germany is that you can see from this photo that we have these manhole covers, and no, not like the manhole covers I have seen in other countries. Here we have this ventilation hose, and this will lead to another topic about should we have them so that the corrosion situation in our shafts will be less severe, or should we remove them so we don't have the odor problems in the city, but there will be more severe corrosion problems in the shafts. So this we can also save it for the discussions later. So anyway, you see with this hose, it brings the problems that underground now above the ground. So the hydrogen sulfide that has been formed in our sewer systems now will emit out through this hose into the city. And then you get the complaints from the citizens that they smell the odor, and that's very unpleasant. And then that's the time when the cities or the municipalities, they need to do something against this odor. So here with this photo, you can have a kind of a clear view about the sulfide transformation, conversion, or formation in the sewer systems. So with long retention time of the wastewater in our sewer systems, it will lead to the fouling smells and corrosion in our pressure pipeline. And these concrete pipelines will be corroded at a rapid pace, which will reduce the lifetime of the pipelines. So that means the city will pay more money for the maintenance or the sanitation of the sewers, and that's not what they want. And that will lead to our solution to it. So in the past, we did this sulfide modeling or simulation kind of like manually with these thousands of the tables. And since the 2014, we combined all these manual tables into a software called Sulfidus, so that we can simulate this sulfide formation generation in our sewers in a faster way. So what does this software do, or what is our solution? Is that we use this software first to digitalize the drainage systems. This information is normally given from the cities, and then we will simulate different complex processes under different situations, or you can say scenarios, the best case, worst case, the standard case. And then we calculate the oxygen consumption and most importantly, the hydrogen sulfide formation. And the results will then be visualized in the map for a better understanding, that everyone can understand where's the problem and how severe is the problem. And this I will also show in the later slides. And yes, with this software, we try to identify the odor emission or the biogenic corrosion development at an early stage. And also for the cities that with the new planning of the sewer systems, we can optimize these systems for the operators and the planners. Sorry. Yeah. The workflow of this Sulfidus can be divided into 5 steps. First, we analyze the input data. This data normally comes from the cities, like I mentioned before. And then we were modeling this sulfide generation with this input data to find out the track of the emission and also the potential damage. Then we have different options against this odor. So we now, after the simulation in the Sulfidus, we kind of have a clear view about how severe is the odor problems in a city. And then we can choose we can choose the optimal solution from the different options that we have. For example, we can using the dosing system, or we can use a biofilter, or the filter that can be easily installed in the manhole, or exhaust air treatment. Yeah, so later from this alternative analysis, we get the results, the options that we want. We need the information for the dimensioning, and we also give the information for the investment and the operational cost and so on. In the end, we will implement these solutions, for example, install the exhaust air treatment, or build in the biofilter or manhole filter, or establish a dosing system. Yeah, so this is the user interface of the Sulfidus, and you can see here is the map of the area of interest, and on the right side is the toolbar where you can draw the wastewater pipeline systems manually with different types, like pure rainwater or pure wastewater, or the combined wastewater, or the pressure pipelines. You can give the input data by clicking here, or review the results with this eye icon, and this elephant here with Sulfidus region on it is the calculation button. And here you can zoom in and zoom out to have a better look of the results. So we have, for the input data, there are some basic data and additional data. And basic data includes like the diameter of this pipeline and length, and also how much water and the basic parameters for the wastewater quality. Additional data includes if we have a secondary inflow, or what type of the drainage system is it, and yeah, and you can see here also operating roughness and so on. The results will be given for each section of the sewer system in a table here, but will also be shown on the map here. So here you can see we kind of visualize these results in a color from green to red, represents low risk or low concentration of corrosion or odor to a very high risk or strong odor. So yeah, the operators or the planners can see from this map here, you see, when you see the red, you saw, okay, that place has the problem of odor or corrosion, and that's very severe, and we need to do something against it. And when it's green, we can leave them first alone. Yeah. So after the analysis or simulation in the sulfides, we have different solutions or recommendations for solving this odor or corrosion problem. Basically, there's chemical or physical solution. The chemical is dosing. We can using different chemicals. And then for the physical solutions, we have compressed air flushing or exhaust air treatment or filter, and so on. So here's a short video showing kind of like explaining the problem with this odor. So you see here we have this manhole cover with the ventilation hose, and the odor is emitting out. And under this manhole cover, you see in this manhole there's much generation of the hydrogen sulfide or any other kind of malodors. So here we have on the left side, we have a pump station, and the water is being pumped in a pressure pipeline, which means there's not enough or just no supply of the oxygen. And later, when the wastewater come out from the pressure pipeline and reaching into the free surface, then the odor will emit out. So here in the past, we have this much of the water consumption, and now the water consumption has been decreasing. So is our wastewater generation. And yeah, that leads to even severe problem with the odor and corrosion in our sewer systems. So you kind of you can detect them on the streets or in your own house, at the public area, like, yeah, anywhere you kind of can detect these odors, especially in Germany when you have this ventilation hose. So we did our calculation and simulation to come out with this software that we can simulate the hydrogen sulfide generation and emission track. And this will help the operators to save the money and give the citizens a better or pleasant atmosphere. Yes, so that's the introduction from our side, and we would like to discuss with you about the sulfide monitoring or simulation applications in your knowledge or in your country, because this is kind of the solutions we found for Germany, which proves to be effective. But we also like to know what other solutions are being used in other countries. But before we go into this discussion, I first want to hand over this microphone to the Professor Bulletin, who will also introduce from his side about some about the hydrogen sulfide simulation.
Thank you. If you unshare, Siqi, then
yeah, you can share.
Yes, exactly. Thanks. Let's see. Yes, it works. So this is the picture from Stockholm, and I really like it. That's really sewer art, right? This statue of the guy crawling out of the sewer. So the hidden assets of the cities. So, but when it boils down to what this is about, I think nobody really loves the sewers. Maybe we love our sewers, but in general, the problem.
We love them.
You love them, yes,
but
you love them, but you're not the public. So if you ask the general public, they do not love them, right? They don't want to know about them. They definitely don't want to see them, like wastewater on the surface, definitely not smell them. They basically want to ignore their existence. But they do definitely want the service they provide, right? So they do want the toilet to work. They do want all the services without interruption of fuss. So it is a hidden infrastructure that is super important, but has a little bit of different life. This is from Morocco it's Tangier in Morocco. And you see, this is actually a really nice place, right? A super nice street and a super nice beach. But what you also see is there are no people at the beach. And then what you also see is, I guess you can see my mouse, there is actually no ice cream shops and so on here. This is a bit weird, isn't it? Because this should be the center of the city. You know, the reason why this is not the case is because there are 3 or 4 parallel huge interceptors with stagnant water, not very well operating, lying in the road here. And if you open the manhole covers, it looks like this, right? Corroded concrete, corroded cement, and so on. You see the wastewater there, really stagnant, and it definitely sort of smells. So you don't want to have your coffee shop and have your cafe latte at the beach, and along comes a whiff of sewage. This is not only happening in this place, it's happening everywhere. This was a very early study we did. I think, I don't know, it was 10 years ago or something we did this. And then we used the software I will come into later on, which we developed. We used that to simulate the system in order to get an understanding. Another case is San Francisco. It's of course a totally different situation, and there was a lot of public fuss about, as you see, a resident turn up noses at sewer stink cure. Actually, it was because the utility tried to put in these thingies here, these ventilation things, and then say, oh, this would help. It did not help. But I mean, the thing is, this is the most touristic area in San Francisco, the Embarcadero, tall ship race, you know, everything, and it stinks of sewage. It's not very good. So also here we went in also quite early on. This is again some of the early studies we did back in, I think, 2014 or 15 on sewer processes. By the way, the very first study I did on big catchments, on really big catchments, was Abu Dhabi in the United Emirates, where we did our first sewer study in 2008. The big one. We also did some before. Another thing you have to keep in mind when you have to think about odors is odors is not odors. In some places it does not matter that it stinks, right? This is the wastewater treatment plant of San Francisco. It does not, it smells horrible. If you come there, it really stinks. It does not matter, because this is really a bad neighborhood. It's so bad a neighborhood that the taxi drivers were not coming down there to pick you up. So I at some point got stuck there and couldn't get away from it. And then then it doesn't matter that it stinks. But if it's Embarcadero, where the tourists are, it matters a lot. So how do we get a grip on all this? How do we get the grip on this fact that sewers are super complex? And how do we keep track of all the chemical and biological processes within them? Because they are pretty complex. Not only the networks, this is an old picture of London, right? Not only the networks, but also what happens in the sewers is pretty complex. From the very beginning, there was this understanding, let's try to model it. It started out around 1947, with the first risk models saying that if your sewer looks a little bit like this, you have a high risk or low risk for odor and corrosion issues. Then along came the empirical models, which are fundamentally speaking 1 or 2 or 3 equations, which you use to predict the sulfide formation, oxygen consumption, and so on. And then it was developed here in Aalborg in the late 90s. We developed a process concept, and this process concept describes, in principle, all the stuff that happens in the sewers, in the water, in the biofilms, in the sediments, in the air, and whatnot. And then, because, as I mentioned earlier, because I am a nerd in programming and coding, I wrote software that could then accumulate all these different processes. I'll come back to that. This is some newer simulations. On the left, you see the city of Aarhus. On the right, you see the city of San Francisco. And again, an overview of where you, in this case, have what hydrogen sulfide in the sewer gas above 1 ppm. So you can do this catchment scale mapping and get a grip on the complexity of the systems you are working at. This is another example also from Aarhus. So here you see concrete pipes with corrosions of more than 10 millimeter per 100 years. So you can zoom in on that. Then you can see all the predicted corrosions in any place in the city. And this is, of course, not the truth. It is the model. So what you would use something like this for is then to see, okay, maybe I should focus my CCTV inspection on certain pipes. So you would go in and say, this is maybe a critical pipe. So maybe I would go in here and do some inspection to see if I really have this bad corrosion as the model predicts, and if the pipe is close at collapsing in this case. Just very shortly to show what the WATS concept does and what the WATS model does. It includes all biological processes, meaning aerobic transformations when oxygen is present, all the anaerobic transformations when nitrate is present, and all the anaerobic transformation, meaning it predicts sulfide, mercaptanes, methane, and whatnot. Anything you want is basically in. It has all the chemical processes, all the oxidation processes, precipitation processes, mass transfer between liquid and gas, the buffer system of the wastewater. And you need the buffer system in order to predict H2S gas emissions. Without that, you cannot really do it, and so on. So it has all these things in it. It has the hydraulics. And it has hydraulics in it, so it routes the wastewater through the network, so it does its own hydraulics in terms of non-uniform flow. It routes the air through the network by balancing water and drag, and then it calculates all the release of gases to that atmosphere. It has all the management solutions you would use in a sewer network. They all in there, and you also can do extreme event statistics using stochastic modeling. And the mathematics behind this is a large number of coupled differential equations which describe all the biological and chemical processes. This idea of writing a process model this way is definitely not new. It started out in the 70s with the activated sludge models, and anaerobic digestion models, also river models using similar approaches. So it's basically doing it the same way as you would do if you want to simulate a wastewater treatment plant with whatever process model. It's just a little bit more complex because sewers are more complex than treatment plants. For the same reason, it can, without any problems, interact with a wastewater treatment plant model because it basically talks the same language. This is, it's not because you're supposed to read all the equations, it's just to show that there's a lot of math behind this, and because it gives a nice, impressive picture, that's why I put it in. So this is just a zooming in and just showing what it does. It calculates each and every pipe meter for meter. This is a piece of San Francisco pipe, 250 meters. You can see the water level, and then you can see how the dissolved oxygen is simulated along the main, and then you can see how this, when oxygen just gets depleted, you then see the sulfide increasing. You then see it decreases again, partly because it's released to the sewer air, and partly because it's oxidized chemically and biologically, and all that stuff is in. Let's go to a concrete example. This is Stockholm in Sweden. This is a force main. And this force main, you can see here, is this is the force main, produces a lot of sulfide around in the summer period up to maybe 10 milligrams per liter. And then in the downstream gravity sewer, it disappears. Here you see the discharge of the force main. Up here, the blue line here is the discharge, is the end part of the force main. So this is this part over here. There you see then the corrosion, and you see it color coded. So red is the worst. So this red is this peak, and you see the yellow is not so bad. It's not so bad. I mean, 1 millimeter per year, right? And then you can see it here. So you can take this model, for example, or this result, I mean, and then you can say, okay, this is a bad corrosion. On the other hand, this is located in a green area. So maybe it's not super critical if it collapses. On the other hand, if this pipe collapses under this 4-lane main street in Stockholm, this really would be a bad thing, because it would just collapse. The rope might collapse and so on, and then you don't want that. So there you can prioritize your maintenance and your management. You can do all the, as I mentioned, all the different solutions, and what solutions you choose. There are many possibilities. Are based on what type of what processes there are. So you can based on, if you understand the processes, you can choose your solutions. I will not go through them all. Then we're sitting here for several hours, but there's the whole palette of what you can think of. Additionally, we also have another model which is linked to the megawatts model. It's MegaVent, and it is a mechanical model. It solves the momentum balance of the airflow. So it's not a process model. It is simply a hydraulic gas flow model, which allows you to predict pressure and air velocities in all the sewer pipes of a network. So that the manhole covers, which Siqi showed earlier, with the holes in it. So you can put basically the size of these holes in the manhole cover in the model, and you can predict if it's a good idea or not to seal the manhole, and what would happen assuming you did it. This of course requires that you actually know the holes in your sewer system, the openings to the sewer atmosphere, and you typically do not really know it. So you should do some pressure calibration and so on, but that's a different story. Things are of course much more complex than I'm just talking about now, right? So there's a lot of work. There's a lot of work for sewer engineers and all this. So we will not be unemployed for the next few millennia. What you also can do is forecasting general conditions. This is I think it's from Stockholm, if I remember right. It might also be from the UK, where we do a lot of modeling. This is what happens in a certain catchment if you increase the temperature. So you can see, for example, that if you increase the temperature, the length of pipe with certain sulfate content increases significantly. You can also do look at what happens, also like Siqi showed, like you're having reduced wastewater consumption. What does that mean for the sulfide? And maybe you have 200 liters per PE per day, for example, and then you decrease it to 140. You can see it will actually have quite a large impact on this catchment on the issues with the sulfide. So you can do this long-term forecasting, climate change scenarios and whatnot. Everything you have one set of the model you can do. By the way, setting up the model, if you have a hydrodynamic model set up, if you know your network, it is of course some work to set it up, but it's not a killer. It's definitely doable. So finally, I would just say that this model is used a lot in the US. It is several of Jacobs, for example, is using it, having maybe 15-20 people using it. A lot of HDE in the US are using it, and so on. So several consulting engineering, especially in the US, who are using it as software. So I think that was it. I can continue forever, but I already promised to talk for 15 minutes. So that's it. Thanks.
Thank you very much, Professor Bulletin. So yeah, we can start our discussion round. And since I have this knowledge, and also before I saw that in Professor Bulletin's presentation, that the temperature of this wastewater would be a very important factor for this hydrogen sulfide. And we before I think sorry for the pronunciation again. Hadi Saitra, you're located in UAE. How is this odor situation in your country?
Yes, yeah. Especially I'm in wastewater field, and we are suffering from the H2S, and we have specific units that treats the H2S. It's a biological treatment. It's the conversion of H2S to acid sulfuric acid. And yes, also I don't know about the others, and it's interesting to know more. But we are reaching approximately 11,000 ppm, between 11,000 ppm and 14,000 ppm, which is like it's the first time that I see here, comparing to my previous experience in Africa and in France, mostly. And also, time to time, as we have the digestion process in our wastewater treatment plant, sometimes when we have high sulfate at the inlet, then we can get at maximum 20,000 ppm, which is this is our historical with H2S.
Yeah, just to comment on that. I mean, what I've seen in the Emirates is that there's a lot of saltwater infiltration into the networks, and that gives you extremely high sulfate concentration. And when you then pair all this with the high temperature, etc., you really get problems. I mean,
exactly.
Can I just ask you, yes, for Professor Follertson, sorry, for the sulfate, in what way is that responsible for H2S? Is there a critical amount? Like we have values from 200 milligrams per liter until the milligrams per liter until 400. What is there a base or a max? Because I heard there's some kind of concentration when I'm above 1,000 milligrams per liter. No, milligrams per liter, then it's not doesn't, or micrograms, it doesn't matter anymore if it's higher.
I mean, what you have, and by the way, my name is Yes, so don't bother with all the formalities. I'm a Dane, so I don't we don't do it. It's totally fine. What you see with sulfate is that the sulfate is converted into sulfide, right? So if there's no sulfate, there would in principle be no sulfide. But the bacteria have a certain above a certain level, they don't need more, if I may say so.
What is
so it is around 5 milligrams sulfides S per liter. And typical wastewater in areas which have no saltwater infiltration is, of course, it changes, maybe 30 milligrams per liter. So you would plus minus, it's not a fixed number, right? So you typically have the potential to produce maybe 30 milligrams per liter of dissolved sulfide, which would cause you a theoretical maximum around 3,000 ppm, depending on pH in the sewer gas. What you heard from Emirates is that the sulfate concentration are much higher due to saltwater infiltration. And then you really can get high, so that this top is not there anymore. But for most networks, Denmark, Germany, you would not have to bother about sulfate, because you typically only have 2, 3, 4, 10 milligrams per liter, far below the sulfate concentration. So you have to keep in the back of your head that in some cases it matters, in most cases it does not. But again, the Emirates, for example, it's clearly matters.
But this concentration will will decrease the sewer life gradually, like completely. So I mean, if the sewer life, the sewage pipes, they, in Emirates, for example, like if they have a high pollution of hydrogen sulfide, like how are these? I'm curious, like how are they coping with it? Like it's hot all over the year. I mean, there's no like temperature variation, but I'm really interested in knowing how they cope with this and do the stuff with the sulfide.
Just to give a single number, I mean, the maximum corrosion you would have in a network is typically around 10 millimeters per year. If you get above that, you get into limitations on the concrete surface. But I mean, a centimeter per year is really a killer for any system. I think in the Emirates, not only in the Emirates, in the hot climates, you have a lot of real issues with corrosion. You can of course manage it by putting chemicals in the network and so on, by lining your pipes and so on. But this also comes with issues. Okay, but are they using any kind of dosing material or any kind of redemptions? Like they need to have a high, if they use something like chemicals dosing, they need to have a high amount of it. Like yes. It costs huge price for them. Yes. I mean, if you want to the Rolls within chemical management, you put nitrate in. Yes. And if you put enough nitrate in, you don't have any problems anymore. But the costs are pretty high.
Especially now with the gas being so expensive, it skyrockets a little bit. All the costs for nitrates and so on. So basically,
I mean, in the ideal world, we would design our system so that we don't have to put chemicals in.
When I started at Unitechnics 10 years ago, my boss always said, the guys that put chemicals into wastewater are evil persons. That's evil. But now I think in some areas, it's just because of something changed, you know, in your, basically in East Germany, we had 300 liters per person because we had communism, you know. So basically water doesn't cost anything. So we designed everything to 300 liters per person. And now we have below 100 because there's capitalism. And then water costs money, so we want to save a lot. And we East Germans are the better capitalists because we never learned social capitalism, as it's called in West Germany. So we can save a lot of water. And we have some areas where we have 70 liters or something per person. And then that's why we have these problems. And then we need chemicals. Little bit.
But I think if you go back to, for example, to the Emirates, you have the deep tunnels. There are a lot of places where you're building deep tunnels. And what you then do is you put a sacrificable concrete layer on it or you line it. However, lining a deep tunnel is a bit risky because when you line it, you believe your liner will actually work. So if you have a concrete pipe, it takes up the sulfide, you get lower sulfide concentrations. Sorry, hydrogen sulfide concentration in the sewer. But when you align it, your H2S concentrations in the sewer go up. But when you have a hole in the liner then, because the liner is not perfect, you can get quite severe concentrations, corrosions behind that liner. And you never see it before the thing collapses. So, and it may happen 10 years from now, right? So it's difficult. And again, I mean, if you build a big tunnel, I mean, you cannot do that in polyethylene, right? Or PVC or something like that, because you can't make the pipes that big. So you have to have concrete structures. And then you have somehow to line them. I was doing a study in Silicon Valley in the US. And there they ended up putting a pipe in the pipe. They simply built a concrete pipe for structural reasons. And then inside that concrete pipe, they made a reinforced glass fiber pipe. So they had a pipe in a pipe. It was expensive.
Well, not everyone can afford that. If I'm not sure.
So you're totally right. You're totally right.
Suppose if you mentioned earlier in your presentation the place in the beach Like there's no ice cream shops or no persons wandering in the beach because it's a nice beach, but nobody wants to go there because of the stink.
Yes.
I mean, does they have any solution, or the situation now rectified, or does it change, or is it still the same ongoing problem for the country?
Unfortunately, still the same. I mean, they try to put chemicals in, but you know how expensive it is, and so it and at the end of the day, the intercepting network sewers are wrongly designed. There's only one way out of it, is this redesigning the network, and you also know how expensive that is.
Yes.
And they also put the treatment plant on the wrong side of the city, so it has all the wastewater has to pass the longest possible way through the city, right? So it is a say it very often happens that people forget to take the hydrogen sulfide issue into account when they design the network, and it comes always as a big surprise. Oh, it stinks. Yes.
Yes, I mean, people now the population is expanding and the city is expanding. The housing complexes are going near to the wastewater treatment plant, which was 50 years outside, like very far away from the city center. Now it's the city expanding, and they are getting new problems, and they never think about it when the city planning. So it's a common issue even in Germany. Like I saw in many cities now, they're expanding towards the city, and then they're having so many problems with the stinky smell, and the corrosion rates are higher, and it's unbelievable.
Yeah. I mean, but it's difficult to get it in the planning. I mean, the case from Aarhus you saw, that's actually a case where the consulting engineering that is doing the work is trying to get this into the planning. So and the utility wants it into the planning. Stockholm is the same thing. They want it into the planning. So now it starts slowly. But it's very, very difficult to get, and it will not happen over in 2 years, right? 20 years, then maybe.
That reminds
we hope
me
so.
of what Professor Fullerton said in our very first kind of the trial wastewater talk, that the planning is more important than afterwards we try to solve this problem. So if we can, at the very beginning, plant the hydrogen sulfide into the designing of the wastewater or sewer system, then we could have maybe avoid this problem instead of after this problem happened, and then we try to find the solutions against it.
Yeah.
It's prevention better than cure.
Yeah. But in very few places it happens. I mean, the San Francisco case, for example, they have 2 odor engineers. Each project that is being made in San Francisco goes over their table, and they model the consequences of any change, and then they give the green light or not, right? And so it's they do it there. But it's the only case I know.
My boss always told me, like 10 years now, when I started in Unitechnics, he told me that a biological calculation of or simulation of the sewer network should be the normal process during the hydraulical simulation. So it should be on top. If you make a hydraulical simulation, you should already do this in the sewers because of the climate change. You know, you have higher temperatures, lower rain events, more heavy rain events. Not so many, but heavier. So you have a lot of water times, but you have times where there's long time no rain, as we had now in April and March here in Germany. So we have, if we have that in summer, we have long times where there's just happening more already in the sewer system. Basically, for every treatment plant, we do this simulation on how the bacteria work. And now in the future, maybe that should be a common process during the network calculation for the future.
Yeah, especially
think about that we have only, like I heard a number like 20 or 30% in the world has sewer networks already. So in the future, it will be a much more needed issue, maybe.
Also in terms of practicalities, if you have set up your hydrodynamic model of a network, setting up the process model is a small task compared to setting up the rest. So it's a small added effort with the large gain.
Okay.
Yeah.
So do we have more questions?
Anybody else wants to bring something, or has maybe a question or something? Yeah, then maybe we want to ask in the round who will be maybe in IFAD in end of May, because that's the last wastewater talk before IFAD now, right?
Mm-hmm.
Next one will be the first Thursday in June, so that will be 1 week after IFAD. I don't know if everybody knows the fair in Munich, so we will have then a special episode on. It's on IFAD, right?
Yeah,
it's on IFAD. We will have a special episode on IFAD. Sorry, where we will be live from our IFAD booth in Munich. And maybe you want to join that, and we can show you our IFAD booth and what's new in our fair. We will have a drone flying through sewers, showing on the fair. And if you want to join, maybe you can show that on video live. Then who's maybe not attending. So basically, is there anybody coming from you guys? Nobody.
I wish.
Okay.
I wish I could go, but no, sorry.
Is that about Corona or cost or?
No, it's about, if you are working for a company, in the end, you need to justify the travel and expenses. And,
okay.
Sometimes I'm for the engineering side. So maybe it's more for managers, so they can have a great time in Munich. And then maybe going again by September to enjoy the beer. So I would say that maybe if they have any virtual webinar sessions, yeah, sure. I would like to attend any stand and for sure yours as well.
Yeah, so if we will make a live session from IFAD on Thursday, 2nd of June, is that Thursday?
Yeah,
Thursday?
2nd of June.
And 10 o'clock again, or 15.
Mm-hmm.
Or in the afternoon.
That would be great. Yeah.
So and Siqi will have her phone with her and make it live with the smartphone, right?
You will have your phone with you.
I will have my phone. Okay, I will do it. So if you guys want to join us, would be very great. Or maybe Jess, if you want to say something about Graz, that's your.
Is the 10th Sewer Process and Network Conference will happen in Graz in Austria in August, and it's a scientific conference, but it's really also focused on engineering and applications, and it's a super nice conference. It's not a big one. We are maybe 100, 150, 170 people. And it's really nice. Last time we had it here in Aalborg, and I was organizing it, and I would move to Graz. And I would love to see as many of you as possible in Graz to the SPN 10.
So Siqi and I will be there.
Yeah.
Hopefully, if there's no Corona again, we will see. But we will be there. So if you want to meet Jess or us, it would be nice to see you there. Maybe we make also a live call from there. We will see.
And you can still submit the summaries now, or?
Yeah, abstracts. Yeah, I could still manage.
Or if you want to insert an abstract, it's from the IWA, right? IWA website. So in August, if there's anybody interested, then okay. And thank everybody for joining us. And see you next time.
Okay, see you.
Thank you, Professor Bulletin.
Bye.
Bye-bye.
Bye-bye.
Thank you, everyone.
Bye.
Bye, everyone.